This is the sixth problem in the exercise 8.1. In the given figure, DE is parallel to OQ and DF is parallel to OR. DF is parallel to OR. Then we have to show that EF is parallel to QR. EF is parallel to QR. Then see, dear students, first we will take the triangle POQ. In triangle POQ, in the triangle POQ, we can see here DE is parallel to OQ. DE is parallel to OQ. By basic proportionality theorem, we can write a line drawn parallel to one side of the triangle divides the other two sides in the same ratio. So we can write here PE by EQ. PE by EQ is equal to PD by DO. PD by DO. This will be the equation number 1. Let us consider the triangle POR. Similarly, in the triangle POR, the line DF is parallel to OR. DF is parallel to OR. Here also we can apply basic proportionality theorem. According to basic proportionality theorem, it is PD by DO. PD by DO is equal to PF by FR. PF by FR. This is equation number 2. In the equation number 1, we received PE by EQ is equal to PD by DO. Here PD by DO is equal to PF by FR. Now this PE by EQ is equal to PF by FR. Therefore we can conclude PE by EQ is equal to PF by FR. Now see the diagram once. In the triangle PQR, PE by EQ is equal to PF by FR. That is the result we got. In the triangle PQR, we received PE by EQ is equal to PF by FR. So by the converse of basic proportionality theorem, the line EF is parallel to QR. Because EF dividing the two sides of the triangle in the same ratio, so it must be parallel to the third side QR. So we can conclude here by converse of basic proportionality theorem, EF is parallel to QR. Now have a look towards this problem. This is also a similar problem what we solved before. In the adjacent figure, here one figure is given. A, B, C are the points on OP, OQ, OR. C, A, B, C are the points on OP, OQ and OR, such that AB is parallel to PQ. AC is parallel to PR. Now we have to show that BC is parallel to QR. See the solution. Take the triangle POQ. In triangle POQ, AB is parallel to PQ. AB is parallel to PQ. So we can apply basic proportionality theorem. By basic proportionality theorem, we can write OA by AP is equal to OB by BQ. OA by AP is equal to OB by BQ. This is equation number 1. And take the triangle POR. In triangle POR again, AC is parallel to PR. AC is parallel to PR. Here also we can apply the basic proportionality theorem. By basic proportionality theorem, we can write OA by AP is equal to OA by AP is equal to OC by CR. Equation number 2. In the equation number 1, OA by AP is equal to OB by BQ. Equation number 2, OA by AP is equal to OC by CR. What happens? This OB by BQ is equal to OC by CR. Now we can conclude therefore from equation number 1 and 2, OB by BQ is equal to OC by CR. Now observe the diagram. Observe the diagram. OB by BQ is equal to OC by CR. In the triangle QOR, OB by BQ is equal to OC by CR. That is the result we obtained. So, by the converse of basic proportionality theorem, we can write BC is parallel to QR. In triangle QOR, by converse of BPT, BC is parallel to QR. This is the next problem, that is 8th problem in the exercise 8.1. ABCD is a trapezium in which AB is parallel to CD and diagonals intersect each other at a point O. Now we have to show that AO by BO is equal to CO by DO. Let us draw the diagram of a trapezium in which AB is parallel to CD. This is a trapezium. This is a trapezium ABCD. In which the diagonals intersect each other at a point O. This is the diagonal BD, and this is the diagonal AC. Both are intersecting at a point O. Now we have to show that AO by BO is equal to CO by DO. We have to draw a parallel line to AB through the point O. So this is the parallel line through the point O. Let us take this point which intersects AD as X. Now, dear students, this OX line is parallel to AB and as well as CD because this is a trapezium. In the trapezium, one pair of opposite sides are parallel, that is AB is parallel to CD already. Now I draw one line, that is OX is parallel to AB, that means it is parallel to CD also. So here we can write, draw OX parallel to AB as well as it is parallel to CD. Now consider the triangle. In triangle ABD, in triangle ABD, this OX is OX is parallel to one of the sides of the triangle AB. So we can apply basic proportionality theorem. By basic proportionality theorem, we can write dx by xa is equal to dO by BO. dO by BO. We can write OB or BO. Both are same. This will be the equation number 1. And take the triangle ACD. In triangle ACD, again this OX line is parallel to CD. OX is parallel to CD. Here also we can apply basic proportionality theorem. By basic proportionality theorem, we can write here AX by XD. AX by XD is equal to AO by OC. AO by OC. Let us write the inverse ratio of AX by XD. Then it becomes XD by AX is equal to OC by AO. Now dear students, here this is dx by xa and this is xd by ax. Both are same only. Both are same, so we can equal do by bo is equal to oc by oa. Then from equation number 1 and 2, we can write do by bo is equal to co by ao. Now we can interchange AO and DO because AO is dividing this side and DO is multiplying this side. We can interchange both. Then we can write AO by BO is equal to CO by DO.